presenter now, Mark Reid of the NASA Jet Propulsion Laboratory, and he'll be giving us a talk on an overview of the Perseverance rover's data management software and improvements since Curiosity. Mark.
Okay, can I just get an audio check? Can you hear me okay?
Yeah, we can hear you, we can see you, and we can see your slides.
Okay, perfect. I guess I'd like to just begin by saying thanks for the introduction, Chris. And it's really good to be back in this community, and I feel really connected here. So with that, I think we'll just go ahead and proceed. So next chart. So the agenda today, this is a fairly short package. The agenda is basically give you an overview of DMS, which is the data management software that's being used on the Perseverance rover. We'll give you some context, the capabilities that are currently provided, also looking back at the capabilities that are provided on Curiosity. And then we'll look at some of the additional capabilities that have been added since Curiosity, which includes some background processing, some Gzip compression and pre-packetization of data products, and querying and reading of existing data products. This is an interesting capability that was added, which allows other onboard flight software to query the current data that's stored on the rover and retrieve existing data products that then can be looked at autonomously on board, which is kind of a nice capability to have to improve performance and provide additional capabilities for the mission. And then lastly, we'll just have a little bit of question and answer time. So next chart. So here's sort of the high level context of DMS. So DMS is the yellow box you see in the corner of the CNDH component. And as far as the total number of modules on Mars 2020 or Perseverance, it's well over 100. So this is one module in a very large system. And within the various components, you'll see the interfaces here. So DMS interacts with various other modules within the CNDH, which include PDP, which I've also worked on, which is the packetization of data products, and also with the file systems for storing, and then with compression. So it's basically responsible for storing, retrieving data products, having them packetized for downlink, and also supplying the interface for compression either by command or autonomously compressing data products as they're closed and migrated off to non-volatile. So that's sort of the context of it sitting in the corner of CNDH. Its interfaces up to other components, like the system component, where it interfaces with CSM, which is our cross-string manager, which lets us basically retrieve and access products on the other rover control electronics string. We have two physical hardware strings, and we could be the prime string retrieving data across, from the cross string for downlink. FSM, which is the, sorry, I'm drawing a blank and I actually don't see it in the key on the right. There it is, the file software manager. But FSM is basically handles start up and shut down and those kind of things. So you do see the key on the right corner there for spelling these out. And then CBM is for communication behavior manager. That controls our communications windows, determines prioritization and downlink comm paths, which DMS uses for retrieving products for downlink. And then in the surface component, you'll see the interactions with imaging and autonomous target selection, which is ATS, which we'll speak about because that's where some of the new capabilities come in. And then on the right, you'll see all the interfaces with the instruments. So there's the Sherlock instrument, the SuperCam, the MassCam with Zoom, MCAM-Z, and Pixel instruments. Those are specifically called out. Other instruments would be viewed as like flight software clients in the upper right corner. The reason I specifically called out the instruments on the lower side, those instruments get some special handling as far as how they store their data products. So this is sort of the big 30,000 foot view context with a lot of interacting modules. So let's go on to the next chart. So here are the capabilities that DMS provides. So from the Heritage Curiosity mission, DMS is responsible for managing all the data products on the rover. And this includes deletion and retransmission of those products. So it includes, by deletion and retransmission, we are not using like a closed loop CFDP. Again, this is inherited from Curiosity. So as data products are downlinked, there's basically a catalog that stores information about all the products. And then that information can be downlinked in what's called a DPSR, a data product summary report. And that DPSR tells mission operations whether products have been completely downlinked, partially downlinked, if they're still open, if they've been closed and pending downlink. So you'll have status information about all your products on the rover through a DPSR, or even a Delta DPSR, which are just what's changed from one DPSR downlink to the next. The ground then uses that information to determine what products get deleted or retransmitted. So DMS is providing that capability to allow them to do that equivalent, ACNAC type handshaking to retransmit or delete products. It also provides, as a heritage, DMS also provides the functions for all the clients on board for creating and writing their data products. So you can think of this as a service layer where you're providing a service to the various clients to do, things such as open products, write DPOs, which are data product objects or portions of products, and then close those data products for migration. So that's sort of the simple, client interface. It's the APIs for those types of services. The third big capability here is for some instruments, the data is actually stored on the instrument itself, not on the rover. And in those cases, the rover provides, or DMS provides, for virtual data products. So we'll put an entry in our catalog to keep track of those products and provide the instrument managers for those instruments. And this is why I kind of called those out on the lower right corner of the previous chart. Provide them an interface to create a virtual data product, which has an entry in the catalog, all the necessary information to go retrieve the product later. And then when it comes time to downlink the product, we will go retrieve it directly from the instrument and bit pipe it through DMS through the downlink and do the packetization. So we're not using the RCEs, the rover control electronics, data storage or non-volatile to store these products. They're being stored on the instruments. The fourth major capability here is saving data products to non-volatile and recovering them after reboot. And this is exactly what it says. So basically we are, as data products are closed or saved by the clients, they get migrated off to non-volatile, and then the rover will go to sleep at night and recharge its batteries. The instruments could still be taking data while the rover is sleeping. And then when the rover wakes up, it basically reconstructs its catalog and continues operations. So then for the LZO compression, which was provided on Curiosity, and you'll see that one of the additional capabilities on Perseverance is we added Gzip in this area. And you can do that for selected data products either by command or when they're closed at migration time. And then we prioritize and downlink the products based on the compass. So depending on which orbiter we're going through, whether it's X-band, UHF, we have different products can be downlinked on those different contacts, whether it's an AM or PM contact. And then it also includes cross-string. So the other area we're going to talk a good bit about today is the additional Perseverance capabilities. And these are the background processing that was added, Gzip compression that was added, the pre-packetization, which we do during migration, and additional functions for clients to go query and retrieve these previously written data products. Next chart. So for background processing, there was a background task. So we have a primary DMS task, and we've added a DMS background task that provides capabilities for mounting the file system following a boot. And this is a performance thing, so we don't end up blocking the rest of the software waiting on the file system to mount. It's being done by a background task. And then we retrieve existing products from non-volatile. And this again goes for, if we want to go retrieve an existing product to look at internally by another flight software module, that's done by a background task. And then also for deletion of products after downlink, again, we provide a DPSR that the ground uses to determine which products need to be deleted. In the past, on Curiosity, they would have to generate a sequence that gets uploaded, and then that sequence uses the command sequence engine and deletes products using that sequence. Instead, what we've done is they can now upload a file, which is basically a listing of the files of the data products to be deleted, and that gets done in the background, and it frees up the sequence engine for other commanding opportunities. So that improves the speed of deletions and also frees up that sequence engine. Next chart. So here's how that background deletion works. So once the operators on the ground have created that deletion list, in the past it would be a sequence on Curiosity, but in Perseverance it's basically a file they'll upload that contains the list of DPs to be deleted. It goes through FVS, which is our file validation or file verification system that ensures that the list is valid. Basically, it has a valid list of app IDs for data products, and we identify our data products using CCSDS app IDs. It has valid time spans. Basically, we're not asking to delete invalid data products or products in the future or anything weird like that. So once it's been validated, DMS then takes that, queries the catalog, where we can have up to 300,000 data products stored on the rover. It'll query that catalog and generate by a list. It's really more of a bitmap, of a map where there's a bit for each of the 300,000 products that says this product's marked for deletion. And once it's built that in step 4, and step 5 in the background, so it hands it to a background task, or in the background, it's just walking through that map, deleting data products, and then coming back on step 6 and updating the catalog to say those products have been deleted. So that's sort of the flow, how this works in a 6-step case. So next chart. So then an additional capability that was added was Gzip compression. And the idea here is as products are migrated from RAM to non-volatile, so a client is finished writing a data product and closes that data product in RAM, sends a close request to DMS to say, I'm done writing this data product. DMS has the responsibility to now move that off to non-volatile. And so the process it goes through is it checks some parameters, and these are, again, uploadable parameters configurable by the operators to say, for each, again, CCSDS app ID that defines a data product, do I want to compress it? And if so, what type of compression am I using? There's a parameter that I can set it to none or Gzipped or LZO to set the compression. And then there's another parameter to say, do we want to pre-packetize this data product? And this is useful for cases that they ran into on Curiosity, where we had some high downlink rates. And if you have a lot of very small data products or data products that have a lot of small DPOs or data product objects in them, if they're being packetized in real time at the time they're being downlinked, it's hard to keep up with the high downlink rate. So the idea here is that we could set a parameter to say, go ahead when we close and migrate this product and packetize it at the time it's placed into non-volatile. And then when it comes downlink time, all we have to do is grab it out and ship it, right? It's already been formatted for the downlink. So the products migrate in stages. They go through this logical check the parameter, do we compress it? If so, do the background compression using Gzip or LZO. For pre-packetizing it, go ahead and work with PDP, the packetization task, to packetize that data product, and then lastly, migrate it off to non-volatile. And then that last migration step is where the file, the data product actually gets removed from the RAM-FS. Once it's placed in non-volatile, we've updated the catalog, and it's then removed from RAM, freeing up space for additional data products. Next chart. So this capability that was added for Perseverance is, I thought was probably the most intriguing capability that we added in this process. And it's the idea of what I would call a reverse migration. So once we've migrated a product off to non-volatile, we want to allow clients to potentially go retrieve that product from non-volatile and move it back into RAM, and then access it, and then discard it out of RAM when they're done with it. So I kind of affectionately have called this reverse migration and discard when done. So it required us to add 4 new client interfaces. One interface that would find an existing data product or a list of existing data products in non-volatile, provide that back to the clients, open an existing data product, which basically is the reverse migration step here. So pulling it from non-volatile back into RAM, then reading DPOs out of that DP, and lastly, closing it in RAM and discarding it. So we don't need to remigrate it. It's already in non-volatile. This is, a client's finished looking at it. We'll go ahead and discard it out of RAM. Next chart. So here was a use case for that. And this is why I, in the context diagram earlier, put ATS on there as sort of a, for autonomous target selection up by image, to kind of emphasize that this capability would be used for autonomously looking at data products on board. And the use case here is we have images that are taken by the various, HAZCAMs, NAVCAMs, MASCAMs. So we've taken various images from the various cameras, and we now want to go later. The autonomous target selection wants to go query these images, these existing data products, based on various selection criteria. And so it can say, give me all the data products with a certain app ID that were created at a certain time, or you could say in the last 10 minutes, in the last hour. So you can do a relative time in the past to say, give me a certain set of data products. And you can query based on other parameters as well. At which point DMS will provide back a list of that matching data products. So that you see on the sequence diagram on the right, ATS says, hey, find some data products. DMS builds a list and says, all right, here you go. So then ATS next would then go and retrieve the data products of interest. So it leaps through that list and says, open a data product, at which point DMS does the reverse migration, copies it into RAM with all the steps on the sequence on the right. And then step 13 basically says, here's your retrieve file. At which point the autonomous target selection can then go read data product objects out of that file and analyze the images for targets of interest. So it can look for, and this is external to my software, so this is in the ATS software, look at various features, or look for specific features based on size, surface reflection, shape, various criteria that have been set up for goals for doing autonomous target selection. At which point ATS could then decide the sequences that have been loaded that are using ATS could then make a decision as far as what targets of interest the rover should go look at next, I guess, without the ground in the loop. So this is providing a lot more autonomous capability. Instead of having to downlink all these images, have the ground do the target selection and uplink a set of commands, they can autonomously make decisions as to which features or items within images they want to go look at. Next chart. Wow. So I actually sped through this very quickly. So I think we will have plenty of time for questions. But I think if we do one more next chart, there's a brief video. So I just can't, that video just gets me so excited. So I'm open for questions.
All right, excellent. Thanks, Mark. So we do have a question in the Q&A, and I encourage other people to start typing. I'm sure you have some questions for Mark. So Edward asked, are the data products contained in a hash table for quick searching? And I think one of your later slides talked about what app IDs and data validity times, and I'm not sure if that's related, but yeah, how are those organized and how do you access them?
So the data products are basically stored in a catalog, which the querying of that catalog, you can query by various attributes. But as far as the searching, they are stored in a tree structure. So the files associated with data products are stored in a tree structure that allows for very quick search and retrieval, or at least retrieval of files, and also for deletions or changing of attributes of the various data products. So one thing I didn't speak a lot about is there are attributes on data products that control like which communications path they can go down on. And those are also commandable and configurable both at creation time and even after a data product's created. You can change the COM path for various app IDs, and you can also set their priorities. There's a lot of prioritization of data products. And to do any of that commanding or reconfiguring of data product priority, COM path, it basically has to go through the catalog to make those updates.
Right, great. Another question from Guillermo. Are there any scientific publications regarding the software on board the Perseverance rover and the DMS in particular that you're aware of?
Not that I am personally aware of. There may be some things, at least from MSL, that Rajiv Yoshi may have published that you could probably do a search on.
Okay. Let's see. Next question from Alexandra Holloway from JPL. She asks, MSL and DMX FSW. Oh, so that's her. What concerns are there with background file system mounting? As you know, we've had issues with mount times in the past as related to COM windows. Are there similar concerns on Mars 2020?
I believe some of those concerns are what are being addressed in the background mounting. And I know the mount speeds are much improved. There was a lot of testing that was done on the test beds where we looked at specifically the mount times, and the mount speeds are much improved from MSL to Perseverance. So we should see a very nice improvement there.
All right, another question from one of our panelists, Brandon Haber. He asked, what sort of performance are you getting in terms of the data per second throughput on the compression algorithms? And was that driven by anything like operations timeliness? Was it driven by any operations timeliness constraints?
Wow. So I actually do not know the answer to that question. So I was not personally responsible for the compression portion of this, just the interface to compression for moving the data products at migration time or by command. So I'm going to have to defer on that. I actually don't know what type of performance numbers we're getting on those.
All right, sounds good. So there's a few more questions, and if you don't mind, we can move those over to Slack. Are you on Slack, Mark?
I am not on Slack. I could probably get set up though.
Yeah, let's get you set up. There's a lot of good conversations happening over there. So I will. So we have there's a channel called Talks, and actually there's just a web link that you can get to. We'll get that sent over to you.
Okay, perfect.
And then that will be in the hashtag Talks channel, where we can follow up with these remaining questions. Thanks a lot, Mark.